Howdy, my name is V.Rivera, and I'm partners with N.England, and this is our Merkle Tree Project Midpoint presentation. So first, starting off, we're going to go over the basic UML for our project. So what we have is we have an abstract basic tree class, and Merkle Tree inherits from this class. And just the basic functions that we have are get height, get head, get the head value, which is the root value, display, and then just other display helper functions. In Merkle Tree, we have a couple of data structures that use array lists, and we have a max size integer. Other notable functions are the hash function, initialize the Merkle tree, delete and insert elements. We get the data size and we get the overall tree size. We also have display, and we have independent toStrings for each class. Within the node class, it's just a basic node class. It has two Booleans that tell you if it has a left child or a right child. There's left and right if you do have a left and right child. And then the basic functions include get index, get left, get right, check if it has a left child or check if it has a right child, and the toString. All of these functions and classes, Nicholas is going to go over in the second part of the video. This is just a brief overview and just a showing of our UML. So now we're going to talk about the actual driver class for our project. So what our project is, it's basically supposed to be like a data reader. And we were thinking that a company who wants to validate their data and store their data and make sure it hasn't been tampered with and get key information about their data can use our program. What it does, it accepts an input file. It reads all the transactions on the file. For example, like this, it will read all of these data points, put them into an array list, and initialize a Merkle tree based on that data. So from that data, there's many different options that can be chosen to do with the data. So first off, I'm gonna just do a simple demonstration. So here we have welcome to Data Reader Pro, and these are all the options that you could do. You could read from a file, you can add a transaction, you can remove a transaction, you can validate your overall data, and you can quit. So first we're gonna just read from the data file, and done. It's read the data file and it has created the Merkle tree. Another thing we can do is we can add a data file, or we can add another transaction. So say I want to add transaction 999. It's done. It's been added to the overall Merkle tree, and the Merkle tree has been reinitialized. Other options include validate data, and this is especially important because that's the main reason we use Merkle trees, is to make sure that data has not been compromised. There has been no breaches or anything like that. So what you can do is you can click for. You can enter a value of the root node to compare. So say you have a root node 45 and you want to compare it to our Merkle tree that we're testing. It does that. And then you click 5 and then it quits. And then it outputs the output file called report.txt. And so as you can see, this is just the display function printing out our original Merkle tree. This one is the Merkle tree with our new node value added, or our new transaction. And then here we have the input root and then the current root. And then as you can see, they don't equal each other. So this means that the data has been compromised or there's an error somewhere. And so what our overall program is to provide a system for companies to be able to check their data, and we will provide recommendations on what they should do if their data has been breached, and we will store their data within a Merkle tree so they have easy access to it as well. And we're definitely going to add more features and functionalities for the final project, but this is what we have so far.
Howdy. So my name's N.England, and I'm going to start off by talking about the classes that are with the Merkle tree. And so first we have the templated basic tree, which has a few functions like get head, get height, get head value, functions that could be used in any tree, and it's templated with the templated node, which I will discuss in a second. And get left, get right, it's just display the tree no matter what kind of tree it is. And so for node, which is used in basic tree, we have Boolean left and right. This is similar to checking if it's no pointer. For like left or right is no pointer, and C++. And then you also have the private index, which is its value in your left and right nodes, similar to any tree. You have constructors, and you have more getters, setters, and toString function. Some of the basic functions that you would need in any class. And then next we have the Merkle tree, which is templated. It is not templated, but it extends from the templated. It uses inheritance. And so we start off with the basic hash function. This function could, as node is templated, this function could be manipulated depending on what your data is in your transaction list. For us, the data is integers, but you could create a way to hash pretty much any type of data that would be used. Some strings could be hashed depending on just what hash function you use. And so we have your basic constructors. If you can just construct a new one and then add new data, or you construct it with the current list. And so this function, it uses array list to initialize the Merkle tree. It's a little bit different from most trees as you start from head to bottom, but for Merkle tree, you start from the bottom to the top as you need to hash the children of the current node. So it's a little bit different. So we used array list to calculate it. You have insert element, delete element. It takes a list that already has, it removes it or introduces it, and then it reinitializes the tree. So when you check the tree after you added or removed an element, it will be the new tree. We have get data size, that returns the size of the list. Get tree size, that's the size, how many leaves are on the tree. Display the tree. This is another, we have an overloaded display function, which determines, which if you put an output file, it will display it into that output file. And then a toString function, and then node, which is a private helper function, which get parent, it determines what the value of the next node will be. And I believe that's it for the Merkle trees and the functions associated with it.